Hello again, dear students. Happy Ramadan for for all of you. And I hope in this month you are be more than energy and we are be more ready for the exercise. So please follow video correctly and carefully. In this video, I'm going to talk about chapter 3, and we are going to section 2 in the chapter 3, which is dealing with the graphing polynomial and end behavior and zero and the shape of the near zero. So please pay attention. Maybe this section is more we have more details. Maybe the video will be longer than the other, so please be with me. In the page 19 we are starting this section, and that's starting by the definition of polynomial. As you know, polynomial in Kurdish we say zorradı der. Polynomial of function means that's a function that with a function with p of x is equal to a in x, b in x, means that something like that. We have p of x like that, so p of x is equal to, for example, or f of x, anything, 3x to power 5, 6x to power 4 minus 2x cubed plus x squared plus 7x minus 6. So this is our polynomial function, and we have a leading term. As I told you before, here's a leading term. It's the first term. We will recall it as a special name. We say leading term, and this is the number 3 is leading coefficient. So these are very important for the shape of for the shape of our graph. If I wanna sketching the graph of a polynomial with something like that, so I will really depend on the leading term and something else. So the leading term is one of the important points for graphing this polynomial. So for example, in this one we have a degree 0, and this is also degree 1, degree square or quadratic, or degree 2 or degree 3, and the leading term is this is the leading term. Also that one and that one is our leading term. So most of them they are important, the leading terms, for the sketching the graph. Now I'm going to the page 91 in your lecture note. 91, page 91. In this lecture I am going to talk about as a review. You know, if this is the graph of f of x, we taught this one, or I talked about this one before in the 2.2. So please review section chapter 2, section 2 is equal to 2.2. You can see the standard form of the graphs. Also, if it's x squared, x cubed, x to power 4, x to power 5. If we have some graph like that, we can sketch it. Also, the example one is the transformation of the standard forms, and this one also you know how to deal with this one, because this is like this shape, and the minus we have a vertical shift, as we taught in 2.3. So please review the section 2.3 for sketching this graph. Now the important things here is what is also this one, the example C. Also it depends on the your information or the background on the 2.3, because I have x to power 5. I know the shape of x to power 5 is like that, and we have minus, and you know the minus will reverse because the minus is outside. We get the reverse of with the y-axis, as we have the graph here. Here's your graph for the part B and part C. So we have this the x to power 5, and this is the x to power 5 minus x to power 5, and because you have a plus 4, we are going to 2, 4, 8. As you see, 6, 8, we are going shifting to a vertically to a forward, and I get something like that. So the first page is just talking about the leading term, and the second page is talking about a review of 2.2 and 2.3 because you need more preparation for this section. So directly another page, we are going to 92 here, 92. In this one, the important things here, because we are nearly to preparation for the sketching the graph. In this one, we are talking about the end behavior and leading term. End behavior and leading term. The leading term, as I told you, they are very important. You have four shape in the leading term, which they are four shape for the polynomial function. And if we have a degree, you know, the degree of the polynomial is the power n, the largest one. As we have before, we say this is degree 0, this is degree 1, because the largest power is equal to 1, and here we say x squared. So because the largest power is 2, we say degree 2, and also we have a degree 3 because the largest is degree 3. That's why we in our lecture we are going to focusing on the degree. So if we have an odd degree, when I say odd degree, I mean, for example, so and behavior. Then behavior, if our power x to power n and plus something that an x to power n an minus 1, we have odd. We means, for example, we have x to power 5 or x to power 3. So we have degree 3 to 1 is standard. For example, you have a 5, 6, something like that. With the coefficients, so we mean by leading term in general is odd, and leading coefficient are positive or negative. So if we have a positive, the shape will be something like that. Okay, so odd and positive. This is odd and positive. Okay, and if we have odd and negative coefficient, the shape will be something like that. Okay, so this one will be like that. Let me do it nicer. This one will be something like that. Means that the end, when x increase, the end of the graph will going to up to forward to the positive. When x going to positive, y also going to the infinite, and when x going to minus, we are going to the left side, like to negative, y also decreased. Y is going to what? Y is going to minus negative. Here, when x, we are in the x-axis and we are going to infinity, y is going to where? Negative infinity, right? Because here is negative part. And here when x going to negative positive, x is going to here, the graph is going to here, y is going to positive. It means that here the shape is very important. Means that if I have O positive, something like that, or you can do it like that. Okay, like a group of the blood, and the shape will be something like that. I know the shape will be something like that. And if it's a negative, okay, the shape will be something like that. Okay, so that's, we mean the end of the behavior of the end, we mean that. For the second part, if we have even leading coefficient is even, like 5x to power 4 plus 2x minus something like this. So because, sorry, 3. So because the leading coefficient is even power, so in the case of even, of course, the leading coefficient may be positive or negative. So in that case, if we have a positive, we have something like W. In case we have negative, we have something like M. The shape will be like M. So here's the E positive and E negative. Okay, it'd be E capital, it's nicer. So before we are starting the sketching the graph, before we are answering the exactly the graph to sketching the graph, you know about the shape. For example, if I'll give you, I say, so this one is talking about this graph. On the page 92, I analyze this graph for you. So odd, positive, odd, negative, E positive, and E negative. Okay. O positive, O negative, E positive, E negative. Okay, dear. Okay. Good. Now we are going to example 2 in page 92. Page 92. Your lecture note. Okay. So you see what? If we have P of x is equal to minus 2x to power 4 plus 5x cubed plus 4x minus 7. Now it's your turn to tell me where's the leading coefficient? Here's x squared, x cubed. Now the largest or the maximum power is our degree. So we have a degree. What the degree is equal to what? The degree is even. So it's equal 4. Okay, where's leading term? Here's leading term is minus 2x to power 4. So E is equal to, you have an even, it's equal, degree is equal to 4, and A, which is equal to minus 2, A is less than 0, means that we have what? We have E negative. So the shape is like what? I know the shape is something like that. It's like M. Why? Because depending on the rules in the page 92, we can, ending the behavior, we can design the shape is something like that. Okay, that's all. For example, to just know the shape. I know it's not to look like my the answer, but in this step, in the example 2, you should just recognize the shape, no more. Okay, it's page 23. We are going to page 24, sorry. Okay, and we are going to example 3. Tell me about this example. You should say we have what? We have x cubed 3x to power 5 minus 5x to power 3 minus 2. So tell me where's the leading coefficient. Here's the leading term. Okay, so you have an odd or even. You have an odd. Okay, so positive or negative? Positive. So all positive is like, the shape is like what? It's like that. So we don't need the more detail here. We just trying to sketch the shape or finding the shape. Okay, dear. So that's all about page 20. Page 92, and in the page 93, the important things here, forget about this one. Okay, just focus on these things. Okay, forget about this one, cancel this one. Just put your attention on this dialog box or this rectangular box. Let's say if P a polynomial and C is a real number, then the following are equivalent. So we have 4 definitions are equivalent. When I say equivalence in the mathematics, when we say equivalent, means that, for example, we have 1000, we say is equal to 4 multiply 250. So they are equal. In the mathematics, we say they are equivalent. Why? Because you have 4 by 1000, so I get 1000, and we have 4 multiply 250 is also equal to 1000. In this case, we say they are equivalent. In math, in Kurdish, we say hawta. We don't say yaksan. Okay? When you say equivalent here, means that these four example, or these 4 points, 1, 2, 3, 4, they are the same meaning, but in the different shape. For example, 0. Look, we have a zeros and 0. Okay? We have a C is a 0. X is a solution. X minus 1 is a factor. C is the intersect with the graph. Now I'm going to clarify these points and why they are equivalent. Okay? When we say P, we have a polynomial, for example, P of x is equal to x squared minus x plus 6. If I have something like that, if I put, for example, C, and if I get 0, then I say C is zeros. Okay, when I say zeros, I mean that. For example, if I put, this is for really for information. Do not make a problem with yourself. Just this for telling you why I say they are equivalent. Okay, so if you don't know how to find this one, I will tell you later how to do it. But just listen to the definition. So I have zeros. Now I'm going to find the zeros for them. For example, if I put 2, I get what? I get x 2 squared, right? If I put here, we substitute 2 in the polynomial, I get minus 2 plus 6. Now, give me a chance. I have 4. So maybe there's a wrong example. Let me fix it. Maybe 5. Okay, maybe 5 now. Okay, so P of 2, not again, sorry. Let me do it for myself before, because I just made it. This example, okay. It will change. Okay, P of x is equal to x squared minus x minus 6. Now I say I'm going to find zeros. If I put, for example, 2, I get what? 2 squared, we substitute here, minus 2 minus 6. So I get what? What again? 4 minus. Okay, I need more work, sorry, give me 1 minute. X. Okay, if I put minus 2, I get what? Minus 2 and P of minus 2 is equal to minus 2 minus 2 again minus 6, because we substitute, put x is equal to minus 2 in here, we substitute minus 2 here, minus 2 and minus 2, so I get what? It's equal to 4 minus minus is equal to plus 2 minus 6 is equal to 6 minus is equal to 0. So C is equal to minus 2 is zeros. How about if I put 3? We'll try. Okay, so I get what? I get 3 squared minus 3 minus 6. Now I get minus 3 is equal to minus 9 is also equal to 3. So C also equal to 3 is 0. So if I say zeros is equal to what? Is equal to minus 2 and 3. So you see, if I put something here, I get 0. Now I'm going to to another definition, to the second definition about the solution. When I say solution, what I mean by solution for the second here, okay? When I mean solution means that if I put the same things here, if I put p is equal to minus 2, I get 0. If I say p is equal to 3, also I get 0. This is also the solution. Why? Because I have what? I have x squared minus 6 is equal to 0. So where's the solution of this example? When I get when value of x is equal to minus 2 or 3. So minus 2 and minus 3 also they are what? Are solution. So this is number 1, number 2. How about factor? What do you mean by factor? Now I'm going to number 3 here. Factor, what do you mean by factor? By factor, you know, if I have x squared minus x minus 6, if I say is equal to 0, I can change it to the factor. So x minus plus 3 by 2. So here's my factor. So x minus 3 and x plus 2 are minus factor. What do you mean by number 4? What do you mean by x intercept? Intercepts means that intersection point. What do you mean by that? I mean that if I sketching my graph, so at x is equal to minus 2 and x is equal to 3, so minus 2, 3 at these points, 3 and minus 2, I'm sure that I have what? I have intersection. I don't know, maybe like that? No. Maybe like that? Maybe like that? I don't know, but I am sure that I have intersection. My graph, anyway, is going to intersect at 3 and 2, minus 2. So means that also x intersection. You can see zeros, solution, factor, and x intersection or intercepts are the same. We got 2, 3. These are the same. So that's why they are very important, because end behavior, do not forget about this one. And I have an important box later, I will tell you. End behavior and zeros are the key of our graph or sketching. Sketching what? Not sketching easy standard form like that. No, it's not sketching something to change it to the completing square and getting the sketch directly after completing square. No, it's the sketching about something like that. X to power 4 minus p of x is equal to 2 4 minus 5x plus 2, like that. Okay, for sketching this one. So end behavior and 2 is zeros. To say zeros, they are very important because they give me x intersect. That's it. Okay, now I'm going to page 94, and here's the question. Here's another example. This looks like our example, but they changed the number. Okay, we have what? We have factor. 0 is equal to 2. 2 is also the solution. Minus 2 is a factor. 2 is x intersect. Also, the same thing happened for minus 3. So do it by yourself. Minus 3 is 0. Minus 3 solution, factor, and go on. Okay. Now, the important box here, as I told you, is what? Is guide for what? Is the guidelines for graphing polynomial functions. They are very important. You need 3 things: 0 and behavior, now test points, so your third key, and finally you can sketch the graph. Do not forget about testing. I think the test points, you heard about test points in chapter 1, Remember that I told you especially for solving inequality in 1.5. Okay, so these test points, they are very important for our for sketching our graph. I'm stopping here the video because I want to go into the another example or telling you about this one in the next video. Okay, dear. So for this one, we will stop here in page 94. Next, we will start with the page 94 and satisfying the guidelines of for graphing the polynomial function.